Dear students, today we'll see multiple choice questions on network theorems, specifically on superposition theorem and maximum power transfer theorem under the subject communication systems. So let's start the topic as DCET multiple choice questions on the subject communication systems part 1, in which we are going to see network theorems, and in network theorems also specifically we will be seeing superposition theorem and maximum power transfer theorem. So let's start with the first question. Question number 1. In superposition theorem, when we consider the effect of one voltage source, all the other voltage sources are dash. So options are shorted, opened, removed, undisturbed. So here, if we remember what was superposition theorem, so there we can see that we had a statement where it stated that in a linear bilateral electrical network consisting of several sources, consisting of many sources, the current through or the voltage across an particular element is equal to the algebraic sum of the currents or voltages produced independently by each source. Now this is important. We have to check the algebraic sum. We have to check the individual source response for that particular element. Now here basically there are two rules. Whenever you want to consider one voltage source and eliminate all other voltage sources, or whenever you want to consider a current source and eliminate all other current sources, or vice versa, whenever you want to eliminate, whenever you want to remove the voltage source, the two terminals should be shorted. And whenever you want to eliminate a current source, the two terminals should be opened. This is the basic theory for answering such type of questions. So here if you read the question again, in superposition theorem, when we consider the effect of one voltage source, all the other voltage sources are shorted. So here option A will be the right answer, shorted. So here we can have the explanation as, in superposition theorem, when we consider the effect of one voltage source, all the other voltage sources are shorted and current sources are opened. This is the theory what we are going to apply for such type of questions. So as we have seen, option A was the answer. So here you can see option A is the answer, that is all the other voltage sources are shorted. Then we'll go to the next question, question number 2 of the same kind. In superposition theorem, when we consider the effect of one current source, all the other voltage sources are dash. Again here it has been asked that what we will be doing with all the other voltage sources which we are going to eliminate. So again the answer will be shorted. If you are considering voltage sources to be eliminated, it should be shorted. So again option A is the right answer here, shorted. So again the same explanation we can give in superposition theorem, whether we consider the effect of a voltage or current source, voltage sources are always shorted and current sources are always opened. So here you can see option A is the right answer because we are going to eliminate voltage source. So A, shorted, will be the right answer. Then we'll go to the next question of the same kind. In superposition theorem, when we consider the effect of one voltage source, all the other current sources are dash. So here we are seeing about eliminating current sources. So current sources should be opened. So here option B will be the right answer, that is opened. So again the same explanation we can give in superposition theorem. When we consider the effect of one voltage source, all the other current sources are opened and voltage sources are shorted. So here we can see option B, that is current sources are opened, which you want to eliminate, they are opened. So B, option B is the right answer. Then we'll go to the next question of the same kind. In superposition theorem, when we consider the effect of one current source, all the other current sources are dash. Again we are seeing eliminating all the other current sources. So all the other current sources has to be opened. So option B again will be the right answer, and we can have the same explanation in superposition theorem, whether we consider the effect of a voltage or current source, current sources are always opened and voltage sources are always shorted. So our current sources are always opened. So here option B, that is opened, will be the right answer. Then we'll go to the next question, question number 5. Find the value of Vx, that is voltage across 20 ohm resistor due to the 16 volt source. So here we are going to consider only the 16 volt source. That means we are going to consider this voltage source. Okay, so 16 volt source, and we have to find what is this Vx. So voltage across this 20 ohm resistor, how much is the voltage? Now here the other sources we have to eliminate. That means we have to eliminate this current source, and we have to eliminate this voltage source, and we have to eliminate this current source. So as we know, current sources will be opened and voltage sources will be shorted. So the circuit will reduce like this. So we will be having the 16 volt supply here. So here you can have plus minus 16 volt, and then we'll have this resistance which is 20 ohms, 20 ohm resistance. Across this we have to find out how much is the voltage Vx. Okay, and then this current source will be opened here, and the above current source also is opened. So both the current sources are open. Then this voltage source will have a short here, and here we'll have a resistance of 80 ohms. 80 ohms. Okay. Now this circuit will be reduced to so much if we have to consider only the 16 volt source. Okay, now we have to find out what is Vx, that is voltage across 20 ohm resistor with this 16 volt source. Okay, now first we will see what is the current through this. Okay, so if you want to find out the current which is flowing through this loop, then we can find it out as current I is equal to voltage, that is 16 volt, upon resistance. Resistance is 20 ohm plus 80 ohm. Okay, so it is nothing but I is equal to 16 upon 100. Okay, so it is nothing but I is equal to 0.16 amperes. So the current which is flowing is 0.16 ampere. Now this 0.16 ampere, when it is flowing through 20 ohm resistor, the voltage Vx will be developed across it. So the voltage across 20 ohm resistor, that is Vx, is nothing but the current multiplied by resistance. So the current is 0.16 ampere and resistance is 20 ohms. So 20 into 0.16, it is nothing but 3.2 volts. So voltage across the resistor to 20 ohm is 3.2 volts. So option B is the right answer here. So here we can see the solving again. When we consider the 16 volt source, we short the 10 volt source and open the 15 ampere and 3 ampere source. From the resulting series circuit, we can use voltage divider to find Vx, and Vx will be nothing but 16 upon 20 plus 80 into 20, that is nothing but 3.2 ampere. So here option B, 3.2 volt. So the option B, that is 3.2 volt, will be the right answer. That is the voltage across 20 ohm resistor. Then we'll go to the next question, question number 6. Find Vx voltage due to the 3 ampere source. So here the two voltage sources will be shorted and one current source have to be opened. Now this circuit, if you consider only 3 ampere source, now this circuit will reduce to, we'll be having a resistance of 20 ohms here, and then this voltage source is shorted here. This current source is going to be considered because we want to consider the 3 ohm current source. So this is 3 ampere our current source, and then here the voltage source will be shorted, and here we'll be having the resistance 80 ohms. Okay, now this will be the circuit what we will get for the above question. So the circuit will be reduced to so much. All other sources are eliminated. Only 3 ampere source is existing. So we have to now find out what is the voltage across this 20 ohm resistor. This is Vx. Now to find out Vx, we will find out first the voltage which is there across 80 ohm resistor. So here if you see, this current is going to flow through 80 ohm resistor. So the voltage across 80 ohm resistor will be 3 into 80, which is nothing but 240 volt. Okay, so this is the voltage. Now that voltage upon both the resistances will give you the current. So the current will be 240 voltage upon both the resistances. If you add them, 80 plus 20. Now this will be current. This is nothing but 240 upon 100. This is nothing but 2.4. Current is equal to 2.4. Now that current multiplied by 20 ohm resistor will give you the voltage across 20 ohm resistor. So Vx is equal to current into 20 ohm. So this is 2.4 into 20 ohm. This is nothing but 48. That is 48 volt. Vx will be 48 volt. So 20 into 2.4 is nothing but 48. So option D will be the right answer here. So here we can see the explanation again. Due to a 3 ampere source, we short the 16 volt and 10 volt source and open the 15 ampere source. From the resulting circuit, we can use current divider to find current in the 20 ohm branch and then multiply it with the resistance to find the voltage. So the current in the 20 ohm resistor will be 3 into 80 upon 100, that is 2.4 ampere. Now that current multiplied by 20 will give the voltage across the 20 ohm resistor, that is nothing but 48 volt. So here you can see option D, that is 48 volt, is the right answer. Then we'll go to the next question, question number 7. Find the value of Vx due to the 10 volt source. Now if you want to consider only the 10 volt source, then the circuit will reduced to so much. Here you can show the circuit. So we'll have the resistance of 20 ohms here, and we have to find out the voltage across the resistance. Now we are going to consider only 10 volt source. So this 16 volt source will be shorted here, and then here the current source of 3 ampere will be opened, and here we are going to consider the 10 volt supply. This is the 10 volt supply plus minus 10 volt supply. The above current source will be open, and here you will have the resistance which will be of 80 ohms. Okay, so we'll be having a voltage source of 10 volt and two resistances of 80 and 20 ohms. Now we want to find out the current due to we want to find out the voltage across 20 ohm resistor due to the 10 volt source. So first we will find out what is the current in the loop. Now this current in the loop will be nothing but the voltage upon the combined resistance. So here the current will be voltage upon the combined resistance. That will be nothing but 10 volt upon 20 plus 80. That is nothing but 10 upon 100, which is nothing but 0.1 amperes. Okay, now this 0.1 ampere is the current flowing. Now this current multiplied by the 20 ohm resistor will give you the voltage. So Vx is nothing but 0.1 ampere multiplied by 20 ohm resistor. This is nothing but 2 volt. So Vx is equal to 2 volt. So option B is the right answer here, that is 2 volt. So here you can have an explanation. Due to the effect of the 10 volt source, we short the 16 volt source and open the 3 ampere and 15 ampere source. From the resulting series circuit, we can use voltage divider to find out the value of Vx. Vx is equal to 10 into 20 upon 80 plus 20, which is equal to 2 volt. So option B is the right answer, that is 2 volt. Then we'll go to the next question, question number 8. Find the voltage Vx due to 15 ampere source. So here if you see this Vx, we have to find out this voltage across 20 ohm, we have to find out due to this source, and all other sources will be eliminated. So here we can reduce this circuit like this. We can have this circuit. This is 20 ohms, and here we are going to find out the Vx, and this voltage source will be shorted 16 volt. This current source will be open, this voltage source will be shorted. So here you can have this resistance of 80 ohms, and here you can have the 15 ampere current source. So here you can have the 15 ampere current source. Okay, now this is the current source and we are having two resistances, and from those resistances we have to find out the voltage across the 20 ohm resistor. So here if you see, we are having only one current source, that is of 15 amperes, and we will be having two resistances of 20 ohms and 80 ohms. Now here if we see the voltage across a 20 ohm resistor, then it should be calculated in this way, where due to 15 ampere current source, 10 volt and 16 volt sources get shorted and the 3 ampere source acts as an open circuit. Since 10 volt source is shorted, it acts as a low resistance path and the current flows only within that loop and do not flow in the 20 ohm resistor, hence the voltage is 0. Okay, so this is a very important thing, the voltage is 0. So here you can see this current is going to pass in this loop only. So here this current is going to pass in this loop only. So therefore there will be no current which is flowing through the 20 ohm resistor. So the voltage across 20 ohm resistor will be 0. So option A will be the right answer here. Okay, so option A is the right answer, that is 0 volt. Then we'll go to the next question. Question number 9. Superposition theorem is valid for dash linear systems, non-linear systems, both linear and non-linear systems, neither linear nor non-linear systems. So here we can have an explanation. Superposition theorem is valid only for linear systems because the effect of a single source cannot be individually calculated in a non-linear system. That means superposition theorem will be valid only for linear systems. Okay, so here option A will be the right answer, linear systems. Then we'll go to the next question. Superposition theorem does not work for, the options are current, voltage, power. Option D is works for all current, voltage and power. So here the answer is power. Okay, so superposition theorem does not work for power, and the explanation is power across an element is not equal to the power across it due to all other sources in the system. The power in an element is the product of the total voltage and the total current in that element. That is why superposition theorem does not work for power. So option C is the right answer, that is power. Then we'll go to the next question, question number 11. A condition for maximum power to be transferred to the load is. Now this comes under our maximum power transfer theorem. So the condition for maximum power transfer is our source resistance should be equal to the load resistance. Okay, so source resistance is equal to load resistance. That condition will give a maximum power transfer from source to load. So here the first option, that is source resistance equal to load resistance, is the correct answer. This is the condition for maximum power to be transferred to the load from the source. So here option A is the right answer. Source resistance is equal to the load resistance. Then we'll go to the next question. In the circuit shown, determine the value of load resistance when the load resistance draws maximum power. Okay, so here we have shown a source of 50 volt, and here we'll be having this as source resistance 25 ohms. Now maximum power will be transferred to the load. Maximum power will be transferred to the load only when the load resistance is equal to source resistance. That means this is equal to 25 ohms. So option B will be the right answer here, 25 ohms. In the circuit, the value of load resistance should be 25 ohms so that it can draw maximum power. So here you can see 25, that is option B, 25 ohms is the right answer. Then we'll go to the next question. Efficiency of power transfer when maximum transfer of power occurs. Okay, so efficiency of power transfer. Now, if you speak about efficiency of power transfer, when there is maximum power transfer from source to load, the efficiency is 50%. So option D is the right answer here. 50% is the answer for this. And for this, we can have a proof here. So here you can see, let us consider this circuit where we are having the voltage. Now this is the voltage, that is the equivalent voltage what we have, a Thevenin's voltage, and we'll have this equivalent resistance of the circuit, that is Thevenin's resistance, and this is the load resistance. Okay, so the IL, that is load current which flows through this circuit, will be equal to VTH upon RTH plus RL. Here we have shown it. Then the load power is nothing but square of the load current into RL. So square of the load current, if you substitute the value, you will get this VTH upon RTH plus RL square into RL. So input power will be equal to VTH into IL, which will be equal to VTH into VTH upon RTH RL. So equation 1 and 2 gives the load power here and the input power here. So these two powers we can use. So for RL is equal to RTH. So the PL will be equal to VTH upon RTH plus RTH whole square into RL. This will be nothing but VTH square upon 4 RTH. So here this is the equation for PL. Okay, so here you can see this is the equation for PL. Okay, this is the equation for PL. Similarly, the equation 2 for PI also becomes as VTH square upon 2 RTH. Now, if you take the ratio of efficiency, that is load power upon input power, this will be 4TH V square TH into 2RL upon 4RL into VTH square, which will be nothing but VTH square RL will get cancelled, and only 1 upon 2 will remain. 1 upon 2 is nothing but 0.5. 0.5 is nothing but 50%. So the power efficiency is 50% for maximum power transfer. So here option D, that is 50%, will be the right answer. Then we'll go to the next question. Under the conditions of maximum power transfer, a voltage source is delivering a power of 30 watt to the load. The power generated by the source is how much? Okay, so under the condition of maximum power transfer, the voltage source is delivering a power of 30 watt to the load. The power generated by the sources, it should be double of that, that is 60 watt should be the answer, because our efficiency will be 50% for maximum power transfer. So that means the voltage sources are delivering a power of 30 watt to the load. That means the power generated by the source is 30 into 2, that is 60 watts. So option C will be the right answer here, 60 watts. So here you can see option C, 60 watts will be the correct answer. Then we'll go to next question, question number 15. Determine the load resistance RL that will result in maximum power delivered to the load for the given circuit. Also determine the maximum power Pmax delivered to the load resistor RL. So two things we have to find out. We have to find out what is the load resistance, and we have to find out what is the maximum power. So 4 options are given about the values of RL and Pmax over here. So out of these 4 options, which option is correct, we have to see. So let's consider this circuit. Now if you consider this circuit, maximum power transfer circuit, so it will be looking like this. We will be having a Thevenin's voltage, which will be our source voltage. We will be having a Thevenin's resistance, which will be our source resistance, and which will be connected to the load resistance. So when load resistance is equal to the Thevenin's resistance, then only maximum power transfer takes place, and the power at maximum power transfer is given with the formula Thevenin voltage square upon 4 into Thevenin's resistance. Okay, so this is the maximum power transfer used in electrical circuits. So for the circuit what is given to us, we will reduce this circuit, and in this circuit we are going to find out first the Thevenin's resistance. So to find out the Thevenin's resistance, we are going to short the voltage source here. So voltage source is shorted here, and only this resistance is taken, that is 30 ohm, and this resistance is taken as 150 ohm. Okay, so they are in a parallel connection, so it is nothing but 30 into 150 upon 180, so that is nothing but 25 ohms. Okay, so 25 ohms will be the Thevenin's resistance. Now we will find out the power also. So to find out the power, we have to first find out what is the Thevenin's voltage. So Thevenin's voltage, that is voltage across AB, that is this point, voltage across this 2 point AB. Okay, so this will be nothing but 150 into 180 upon 150 plus 30. Okay, that means this is nothing but our 180 voltage. So if you see this in this way, 180 voltage upon 150 plus 30 resistance. So this will give you the current. This multiplied by 150 will give you the voltage across 150. This is nothing but 150 volt. Okay, so from this we get the Thevenin's voltage as 150 volt, and from the formula of maximum power we can have this Thevenin voltage square upon 4 into Thevenin resistance, which will be substituted as 150 square upon 4 into 25, which will be nothing but 225 watts. So maximum power is 225 watts. So here you can see option 4th, that is 25 ohms and 225 watts. RL is equal to 25 ohms and maximum power is equal to 225 watts will be the right answer. Then we'll go to the next question, question number 16. In the circuit shown above, the maximum power absorbed by the load resistance RL is how much? So we have to find out what is the maximum power. Okay, so to find out maximum power, we have to find out the Thevenin's voltage and Thevenin's resistance. So here we'll see in this maximum power formula will be so much as we have seen earlier also. Pmax is equal to VTH square upon 4TH. If you have to find out VTH, then we have to consider the circuit like this, and the terminals, these two terminals, across these two terminals, whatever voltage we are going to get, that will be our VTH. Now here, by applying the voltage division rule, we get this as 18 volt upon 12 plus 6 ohms into 6 ohms. So this is nothing but 6 volt. Okay, so VTH, that is the Thevenin's voltage, is 6 volt. Then if you want to find out the Thevenin's resistance, we have to short circuit the supply here, and we have to consider the 12 ohm and 6 ohm resistance. They are in parallel, so it will be 12 into 6 upon 12 plus 6. This will be nothing but 4 ohms. So RTH will be 4 ohms. So Pmax is nothing but VTH square upon 4 RTH, which is nothing but, if you substitute the values, you will get 2.25 watts. So 2.25 watts will be the right answer here. So here the second option, that is 2.25 watt, is the correct answer. It is the maximum power absorbed by the load resistance RL. Then we'll go to the next question. Question number 17. For transfer of maximum power in the circuit shown in figure 1, the value of RL should be how much? So here we have to find out how much is the value of RL. Now to find out the value of RL will be, if you have to take the equivalent R resistance of 4 ohm, 6 ohm and 5 ohm. So if you take the equivalent R resistance of 4 ohm, 6 ohm and 5 ohm, we will see that 4 and 6 are in parallel, and that parallel combination is in series with 5 ohm. So here you can write it like this. So here we can write it like this: 4 into 6 upon 4 plus 6 plus 5. Okay, so it is nothing but 24 upon 10 plus 5. It is nothing but 2.4 plus 5. This is nothing but 7.4 ohms. So the equivalent resistance, the value of RL, should be equal to RTH. So RL will be also equal to 7.4 ohm for maximum power transfer. So option 3 will be the right answer here, 7.4 ohms. So here you can see 7.4 ohms is the right answer. Then we'll go to the next question, question number 18. What will be the maximum power that can be distributed in the load in the given circuit? So what is the maximum power that can be distributed to the load here? So this is the load RL, and what will be the maximum power? Now again, for this we have to find out the Thevenin's voltage, we have to find out the Thevenin's resistance, and then we have to find out the maximum power. So here if you go to see the equivalent circuit, it will be looking like this. Thevenin's voltage is in series with the Thevenin's resistance here, and that will be in series with the load resistance here. So RTH should be equal to RL for maximum power transfer. Okay, so here if you see, if you short circuit the voltage source and find out the RTH, then this resistance is 2 ohm, 12 ohm, 5 ohm and 3 ohm will give you the equivalent resistance RTH as 6.68 ohms. And then if you find the VTH, it will be around 3.15 volts. Now after getting VTH and RTH, we can find out the maximum power as we have seen earlier also, and then the maximum power is nothing but 0.377 watts. So here option B, that is 0.377 watts, will be the right answer. Then we'll go to the next question. Question number 19. The output resistance of a voltage source is 4 ohm. Its internal resistance will be how much? Now if output resistance of a voltage source is 4 ohm, then for maximum power transfer, its internal resistance also should be 4 ohms. So option A will be the right answer here, 4 ohms. So here you can see its internal resistance should be also 4 ohms. Then we'll go to the next question. The maximum power transfer theorem is used in. Options are electronic circuits, power system, home lighting circuits, none of this. So obviously it is electronic circuits in which we use the maximum power transfer theorem. So option A is the right answer, that is electronic circuits are one in which maximum power transfer theorem is used. So option A is the right answer here. Thank you, students.